Let us now discuss how can we solve this problem. Longest binary subsequence less than or equal to k. So let us see what is given in the question firstly, right? You are given a binary string s, that means we will be having in a binary string only zeros and ones and a positive integer k. Return the length of the longest subsequence of s that makes up a binary number less than or equal to k, right? So we need to make up some binary subsequence. Now let us see what is this subsequence. A subsequence is a string that can be derived from another string by deleting some or no characters without changing the order of the remaining characters. So if I delete some of the characters and consider the other characters, right? Like here, I have just deleted 0, 0 and another 0. So 0, 1, 1, 0, 1. This will be my subsequence. That means I am not changing the order if you see. So without changing the order and by deleting some or no characters and right, we are not changing the order of the remaining characters. Now that makes up a binary number. Now 0 1 0 0 1 makes some binary number. Like here, it would make 1 2 4 8. 8 plus 1 9. And they said that the subsequence can contain leading zeros. That means this string, right? This subsequence is having a leading zero, but it is not any problem for this question, right? So we can consider the leading zeros and the empty string is considered to be equal to 0. So if we didn't take any string, that means if we take an empty string, right? If we take an empty string, then the value of it will be 0. Now let us see at an example and let us understand how can we solve this problem. First thing, here I have 1 0 0 1 0 1 0. First of all, if I take this 0, let me take it. Now, what will be the value of this 0? Just 0. Why? Because at the zeros place, I have here 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, and so on, right? So 0 into 2 power 0. 0 into 1 is just 0. Now I got this 1. Now when I add this 1, I have the value as not 0. 1 into 2 power 1 plus 0 will give us 2. But let us see, is this 2 lesser than k? Yes. Then we can just consider this 1. Now let us consider this 0. Now if I consider this 0, it is saying that 2 power 2 into 0 is nothing but just 0. Something into 0 is just a 0. Now I have 1 again. 1 into 2 power 3. What is this? 2 power 3, right? 2 power 3 is 4 into 2, 8. Now, if I add this one, 8 plus 2 will become 10. So, what I have to do is just not consider this, right? I am just deleting it. Now, I have this 0 at 2 power 4. Now, 0 into 2 power 4 is just a 0, right? And again, 0 into, let me write it, 2 power 5, 2 power 6. 0 into 2 power 5 is just a 0. 1 into 2 power 6, 32 into 2 is 64, right? 2 power 5 is 32 into 2 is 2 power 6, which is 64. So it is exceeding 64 plus 2 will be 66. So it will be exceeding. So what I'll do, I'll just not consider this one. Now, every time I'm considering an element, I will increment the size. Here, 1, 2, 3, 4, 5. So the size of the subsequence is 5. Now let us look at this example where we have given with k is equal to 1. Now what I'll do is just take this 1 firstly. 1 into 2 power 0 is 1. And if I take this 0 into 2 power 1 is just 0. 0 into 2 power 2 is just another 0. 1 into 2 power, 1 into 2 power 3. 2 power 3 is 8. 8 plus 1 will give us 9. So, which is exceeding the limit of k, which is greater than k. So, I will not take this one. Instead, let me take 2 power 3, 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8, right? So, I didn't take this 2 power 3. Now, let me take this 0. 0 into something is 0. Now 1 into 2 power 5 is nothing but 32. 32 plus 1 is 33, which is exceeding k. Now I'll not take this 1. Now after that, let me take this 0 and put it here. 0 into something is 0. No need to worry about it. 0 into something is 0. Now what is the size is 0 or 1 0, right? I'm just counting the size. 1, 2, 3, 4, 5, 6. Now, if I have to write the algorithm, I'll start with the size as 0 and the value as also 0 and j is equal to 0. Right. Now, I will start from for I is equal to s dot size minus 1 and I is greater than or equal to 0, I minus minus. So I'm going from the back. Why? Why? Because I'm just adding 0. I'm just multiplying the zeros with zeros or ones with 2 power 0, 2 power 1 and all. Now the j represents these powers, right? Now let us see. Here, now if value plus s of I minus 0 into this number 1, it might be 1 or it might be a 0 into power of 2 comma j. If it is greater than k, just continue. But before that, I need to increment the j value. So j plus plus, right? So value plus s of I minus 0 into power of j. If it is greater than k, then just continue. And before continuing, that means before skipping this, increment j. Now, else what we need to do? Value plus equal to s of I minus 0. I am taking the digit into power of 2 comma j. Now, I got the value and after that I will increment the j, right? That means the power, right? And after that I am taking this, right? If it is not true, if it is not greater than k, else this will be satisfied. Then what I need to do, I'll just increment my size and return size at the end. So this is how we write the algorithm for this. And if you like this video, do share to your friends and do subscribe to my channel. If you have any doubts, please comment in the comment section. Thank you.